So we're going to talk about systems of equations again, substitution again, but this time we're going to look at problems that are a little bit harder. And they're going to be harder in a couple of different ways. So let's start out with this one. Oops. So this problem you can't tell yet why it's harder. But I think it is a little harder than the ones that we've been doing. So let's do what we know to do. We have y equals, I'm going to find y down here, circle it. And I'm going to rewrite that second equation, except instead of y, I'm going to write some parentheses. What do I put in those parentheses? I put this. This is what y equals. So I'm going to substitute it in here where I used to have y. So I write x plus 3. Okay, now I need to use the distributive property. So I have 4x plus 2x plus 6 equals 20. Subtract 6 from both sides. Combine my like terms. 4x plus 2x is 6x. Subtracted 6 here to get 0. 20 minus 6 is 14. Now we see why this is a little bit trickier. When I divide both sides by 6, x equals 14 sixths. 14 sixths. That's a fraction. I could reduce that. If I take a 2 out of the top and the bottom, I'd have 7 thirds. So x is 7 thirds. It's a fraction. Is that possible?
Yes.
Yeah. Why not? Fractions are numbers too. Now I can find y by plugging in x up here. So x is 7 thirds plus 3. How do I add 7 thirds plus 3? I have to get the same denominator. So if I think of 3
over 1.
as being 3 over 1, good. Now I need to make my 3 over 1 into something over 3. I'm going to multiply the top and bottom times 3. Y equals 7 thirds plus 3 times 3 is 9 over 3. Oh, now I have thirds in both terms. So now I can say y equals 7 plus 9 is 16 thirds. So my answer is 7 thirds, comma, 16 thirds.
Can't you reduce 16 thirds?
3 is a prime number. 16 cannot be divided by 3 evenly, so I can't reduce it. If it had been 15 thirds, then I would have been able to, right? Because I would have been able to take a 3 out of 15 and another out of 3. I could turn these into mixed numbers, though. 7 thirds would be 2 and 1 third. 16 thirds would be 5 and 1 third. Same thing. Typically in algebra we won't do that. I'll just leave it like that. But if you had to graph this, it might be useful to turn it into mixed numbers. Alright, so we could have fractions. It's possible that we get a problem that has a fraction. What else might we have? Well, let's look at a problem like this. Y minus x equals 4. 3x minus 2y equals -7. Now when you first see that, you might say to yourself, I'm kind of hoping you say to yourself, wait, we have x and y on the same side. Why don't we solve this by elimination? Why don't I add something together, right, and try to eliminate? You could do that. It's totally possible. I'm going to ask you on the homework tonight not to. So even when x and y are on the same side, I don't want you to try to eliminate. I don't want you to use the elimination method tonight. If I were to give you a quiz or a test, it would be totally fine, however you'd want to solve it. If I said solve this system of equations, you have the option then of using elimination or substitution. But for tonight, we're always going to solve with substitution because I want to show you how to do this. And actually, I think this problem is easier to solve with substitution. So what do? I don't have y equals, and I don't have x equals. I don't have a variable isolated on one side. Should I start crying? No, that's not going to help. I mean, I could cry a little bit, but then eventually I want to look at the problem and figure out how to solve it. So if I look at this top equation, I have y here, right? There is a y. It's just not all alone.
Add x to the side.
I could add x to both sides. I could. So if I added x to both sides of this equation, now it would turn into y equals 4 plus x. Now I have y isolated. I have y all alone. So if I have y alone in this equation, let's find y down in the second equation. Instead of that, I'm going to write this. So let's rewrite the second equation. 3x minus 2 parentheses equals negative 7. Inside my parentheses, I'm going to write 4 plus x. Actually, I'm going to write x plus 4. Is that the same thing? Is x plus 4 the same as 4 plus x?
Yes.
Yeah. It's addition, so I can switch them up. Okay. Distributive property. But watch out for this distributive property. I am distributing negative 2. Not just 2. Negative 2. So I have 3x minus 2x minus 8 equals negative 7. Why isn't it plus 8? There's a plus right here.
Because it's negative, the 2 is
The
negative.
2 that I'm multiplying times the 4 is negative. So it has to be minus 8. Plus negative. Okay, 3x minus 2x is x. Minus 8 equals negative 7. Add 8 to both sides. X equals 1. Ooh, I did it. Now I have to find y. Let's use this equation right here. The one that I changed a little bit to find y, because it just tells me y equals 4 plus 1, so y is 5. It's pretty quick if I use this equation to solve for y. So my final answer here, 1, 5. So this was the key step. Figuring out that in this equation, I could add x to both sides in order to isolate y. That's a new step. Everything after that was the same as what we've been doing. Okay. Anyone want to take a picture of this one?
I wrote it all down.
You got it all down? All right. Let's try it again. says substitution, so I have to solve this with substitution. But I don't have x equals or y equals. Does anyone see an easy way to get one of these equations to say x equals or y equals?
Or subtract the x out.
Subtract the x? From which one?
Either one.
Oh, you're saying with elimination. Yeah, we totally, like, this is probably how I would actually solve this problem. I would use the elimination method, multiply through by -1, add them together. But that's not what I'm asking for. What I'm asking for here is, if we had to solve this with substitution, how could we make it say x equals in just one of these equations? X equals something y, or y equals something x. Yeah, Maddie.
It's subtract 2y from 8.
Yeah. If I rewrite this top equation, x plus 2y equals 8, I could get this to say x equals if this 2y weren't here. So I just subtract 2y from both sides. Now this equation says x equals 8 minus 2y. Oh. Now I could use substitution. In my second equation, right, I've already used that one. In my second equation, I'm going to find x. I'm going to put this in instead of x. So, parentheses, plus 3y equals 12. X plus 3y equals 12. But in this case, x is actually 8 minus 2y. Okay, these parentheses aren't really important. There's nothing being multiplied, so I can just ignore them. Here I have minus 2y plus 3y. How many y's do I really have on that side of the equation?
2.
I have 3 here,
1 y.
and minus 2 here. Yeah, I really just have 1 y, and then I have an 8. A positive 8, right? And a positive, they're all positive because the negative combined with that 3 to get positive 1. Subtract 8 from both sides. Y equals 12 minus 8. It's 4. Now I have to find x. Let's use this equation. X equals 8 minus 2 times 4. X equals 8 minus 8. So x is 0. My answer is 0. And if we had done it John's way of adding these together or subtracting them, we would have actually gotten the same answer. So elimination and substitution are just two ways of solving the same types of problems. I just want you to see that you have multiple options, right? We could solve this with substitution. Subtract the 2y so that we have x equals. Did you guys get that all down? And you want to take a picture of that one? Alright. There's one other thing that could potentially make these equations a little bit harder. This actually, the problem that I'm going to do right now is problem 6 on your homework. So, on your homework, I would like you to actually write out the steps as well. Don't just put in the answer. But you'll have this little guide, if you take good notes right now, to how to do problem 6. 2x plus 2y equals 2. Negative 4x plus 4y equals 12. This really does not look like a substitution problem. I don't have x equals. I don't have y equals. I don't have any variables isolated. Not only that, I don't even have just a 1x or a 1y anywhere in this entire problem. But we have to solve it with substitution. That's our challenge. So we have to find a y equals or an x equals. We have to make one of these say y equals. There's a lot of ways to do this. But here's what I would do. I would look at the second equation and I would notice that x is negative here. So I'm going to add 4x to both sides. Plus 4x plus 4x. Now at least I have y on one side and x on the other. I'm going to write 4x plus 12 instead of 12 plus 4x, but it doesn't really matter. I still, though, I don't have one y here. So, still not quite there. So now I need to divide everything by 4. Divide both sides of this equation by 4. I get y equals 4x divided by 4 is x. 12 divided by 4 is 3. Oh, y equals x plus 3. Wait, are we saying that negative 4x plus 4y equals 12? Are we saying that that is the same equation as this? That seems kind of crazy. But if you were to graph these, if you were to graph both of those lines, negative 4x plus 4y equals 12, we would start by making a t-chart. We would end up with 1, 2, 3, a y-intercept of 3, an x-intercept of negative 3, and a line going like this. If we were to graph this, we would start up here at 3. We would go up 1 over 1, up 1 over 1, up 1 over 1, or we could go down 1 over 1, down 1 over 1, down 1 over 1. They really are the same line. This really is the same equation as that. All I did was add x, divide by 4, did the same thing to both sides. Anyway, that's just kind of an aside. You don't have to do that to solve this. But this equation could be rewritten as this. Now that I have y equals x plus 3, I'm going to circle my x plus 3 here. I'm going to go back to the other equation, this one, and find y. Now I'll rewrite this whole equation, except instead of y, I'll put this. 2x plus 2, for now I'm just going to put parentheses, equals 2. As I'm reading through that, I just put parentheses where I had the y. Now I go back to see what y equals. Y equals x plus 3. Let's put that inside those parentheses. Okay. Now I need to use my distributive property. 2x plus 2x plus 6 equals 2. Okay. 2x plus 2x is 4x. Plus 6 equals 2. I'm going to rewrite it up here. 4x plus 6 equals 2. Subtract 6 from both sides. 4x equals negative 4. Divide both sides by 4. X would be negative 1. Now I can find y by plugging x into that equation. Y equals negative 1 plus 3, or y equals 2. So my answer here is negative 1. This is the new stuff, right? New stuff. Everything else is just what we did yesterday. The same stuff that we did yesterday, the sum piece. Questions on that one? If you copied this down, you now have a guide in your notes for which problem on your homework?
6.
Problem number 6, right? So when you get to problem 6 on the homework, you can look back in your notes and it will show you how to do it from beginning to end. All right.